Assalamualaikum. Hi guys. Let's continue with the chemical reactions of carbonyl compound. We are going to focus to three more, which is the first one is reduction, and the second one is condensation, and the last one is oxidation. So let's go with the reduction first. So reduction to alcohol, this is where you are going to reduce aldehydes and ketones to primary and secondary alcohols respectively. So this is where you are going to use reducing agent. So the common reducing agent that you should use is LiAlH4. This is what we call as lithium aluminium hydride, or the short form yang saya selalu akan sebut adalah LiA. And then this is followed by H3O+. The second one is NaBH4, sodium borohydride in methanol. So methanol means that you have CH3OH. Yang saya selalu guna adalah term ini NaBH. And then last one we have catalytic hydrogenation, where you need hydrogen in catalyst, either platinum, palladium or nickel. So let's take a look one by one. When you want to reduce carbonyl compounds, you should take a look whether that carbonyl compounds is aldehyde or ketone. So first thing first, I'm going to identify this one is aldehyde. So I have my reducing agent followed by the hydrolysis, LiA and H3O+. So I'm going to reduce this aldehyde to primary alcohol. So the first part that you should take a look at the reactive side. Reactive side biasanya dekat bahagian functional group. So kita ada functional group which is carbonyl group. So I'm going to change this carbon. Okay, this first carbon, if I give the numbering, this first carbon akan bertukar menjadi alcohol, di mana dia akan jadi hydroxyl. So I'm going to copy back this first carbon, attach to OH, and then the rest of it follow the same as before. And then you got this structure, but this carbon is not enough yet with the bond. So saya akan tambah berapa lagi bond? Saya ada 2 lagi bond. Dia akan attach kepada hydrogen. So I'm going to put CH2. So you got your answer for the first structure A. So this is our primary alcohol. Next one, we are going to continue structure B and C. So what I have here is benzaldehyde. So this is aromatic aldehyde. Same goes here, you have NaBH and methanol. And then I'm going to change my position of functional group from carbonyl. It's going to change to hydroxyl. So I'm going to have my this carbon attached to OH and then attached to my benzene ring. This is my benzene ring and I'm using the circle in the middle of it. And then you got 2 more bonds for carbon. It will attach to hydrogen. I can also write it down as this part. Okay, so like this is also acceptable. So you got your primary alcohol. Be careful, this is aromatic aldehyde, but this one is primary alcohol, not aromatic alcohol, because aromatic alcohol is only for phenol. So please take note about that. Next one we go for question C. Question C, you have catalytic hydrogenation using platinum as my catalyst. I have ketone. So this ketone, I'm going to change the carbonyl group here into hydroxyl. So just copy the structure back. So I'm going to have this one, 5 carbon atoms in the ring attached to OH. So what you have here is this carbon is our secondary carbon. So automatically this one is our secondary alcohol. So it is proven when you reduce aldehyde you will get primary alcohol. When you reduce ketone you will have secondary alcohols. Next we go for condensation with ammonia and its derivatives. This is the process when you condense the water. So condensation is where you are going to combine 2 molecules to form larger molecules. So when you combine, you have to take a look what you should eliminate. So we are going to eliminate small molecules such as water. So condense maksudnya kita buang air. So buang air dalam kes ini macam mana I want to get rid or eliminate the water molecules. Please make sure you understand that water molecule, it will have the formula H2O. So we have aldehyde here or ketone. This is our carbonyl group. and then you have ammonia. I'm going to choose ammonia with its functional group. Usually functional group for ammonia is amino. So this is amino attached to Z. Z here can be any derivatives of amine. We are going to discuss later on after this. And then you have to undergo with hydrolysis or acidic condition. And then what happened here, you are going to get rid of oxygen from the carbonyl group and hydrogen H2 from amino group. So what happened? Combine this together. So C here will be double bond to nitrogen, and then followed by Z at the right side for the nitrogen. And you have your water as the side product. So which one is the molecule that you combine? This one. So this is the big molecule that you combine from your carbonyl compound with ammonia derivatives. And then the big group here, we call it as imine. So this is an organic compound that contains carbon double bond nitrogen. Alright, let's continue. In the reaction before, in this equation, you have Z. So as I mentioned before, Z is ammonia and its derivatives. So for example, you can use Z as hydrogen. So you got NH3. And then next one, you got Z as alkyl group. For example, you got primary amine. If you have Z as OH group, it can be hydroxyl amine. And then if you have NH2, so NH2 attached to NH2, this is what we call as hydrazine. And last one, your Z attached to NPH. PH is referring to phenyl. So phenyl is our benzene ring as the substituent. So this is what we call as phenylhydrazine. So what I'm going to explain to you, if you got derivatives of amine, take a look carefully. It doesn't matter, but make sure you understand you are going to condense the water. So if you have ammonia and primary amine as your reagent that reacts with carbonyl compounds, you will form imine as the product. The others, apart from these two, you are going to perform another different kind of products. But you should understand, this is where we are going to combine at this bond. So this bond is the combination between carbonyl compound and ammonia with its derivatives. So we got a few examples here. So I'm going to try A. So what we have here is benzaldehyde reacts with ammonia, undergo hydrolysis. Don't forget, this is our extra reagent. You can also use H+, it is also acceptable. And then what I have here, I'm going to condense my reagents from ammonia. We know ammonia has 1 lone pair and 3 hydrogen. So I'm going to take 2 hydrogens from ammonia, so this one, and oxygen from carbonyl compound. And then we are going to combine from this carbon double bond O attached directly to nitrogen and hydrogen. So let's copy back the structure. We have our benzene. This is our benzene. Don't forget to put the ring in the middle or double bond. And then you have carbon. This carbon you attach with hydrogen, and then you have double bond O. So this is enough for carbon with 4 bonds. And then it will directly attach to N. And then N here you got 1 hydrogen. Nitrogen maksimum dia boleh buat adalah 3 bonds sebab dia ada 1 lone pair kat sini. Sebab tu dia akan ada 8 electron, octet. And then don't forget you get one more structure iaitu side product H2O. Very simple. Let's go with the second question, B. So what I have here is our carbonyl compound. This is ketone. So I'm going to eliminate oxygen and 2 hydrogen from here. So I'm going to combine back the structure into the bigger molecule. Draw your cyclic ring first with 5 carbon atoms, and then this double bond will attach to nitrogen, and this nitrogen you have CH3 beside it and plus with H2O. So you got your structure when you have primary amine. So this is imine. Next one, we have our aldehyde reacts plus with hydroxylamine. So this is hydroxylamine. So when you want to condense, just same as before, the same concept, you are going to get rid the O from carbonyl group, and H2 is coming from the hydrogen that attached to nitrogen. So I'm going to combine all together. So the structure will be C, and then you have CH3, and then after that you have hydrogen. This is double bond, and then it will connect it to nitrogen with OH group. So actually this nitrogen has lone pair, same goes for here. And then you don't have to show the lone pair, it's okay, but at least I want you to understand that this nitrogen is octet, and then plus with H2O. So you got your structure, and this product is what we call as ozine. Next we go for structure D. Structure D, what I have here is when you have N2H4 reacts with carbonyl compound. So this is our hydrazine. If you want to know more detail, N2H4 can be drawn as N bonded to N, and you got 2 hydrogen for each of them. So this is what we call as N2H4. And then this hydrazine undergo with acidic condition. You are going to condense. Ingat, kita nak eliminate water, O daripada carbonyl. And then untuk hydrogen, kita ada dua pilihan daripada mana-mana salah satu nitrogen. Pilih sahaja. So awak pilih daripada this side, and then you are going to condense from the water. So the rest of it kita akan combine. So you will have carbon double bond, and then you have CH3 at the top, and this is our nitrogen, and this nitrogen is bonded to another nitrogen because this is first nitrogen, this is second. Okay, if you want to take a look carefully. And then after that, this second nitrogen, you have hydrogen, 2 of it. And then don't forget your carbon should be enough with 4 bonds. So this is the structure that you have plus H2O. So the name of this product is what we call as hydrazone. Let's go with the last example, example E. So what you have here is aldehyde. So I'm going to get rid the oxygen from carbonyl group, and then this is what we call as phenylhydrazine, this one. So when you have phenylhydrazine, take a look at the last structure of nitrogen, which is we are going to take 2 hydrogen from this nitrogen, okay, the one at the end. And then I'm going to combine the structure. So let's start with our carbonyl compounds. So we have CH2, CH3, and then bonded to carbon, and then we have 1 hydrogen, and then double bond attached to nitrogen, and then you have nitrogen, 1H. If you want to draw it like this, also acceptable. And then this nitrogen bonded to benzene ring. Don't forget your benzene ring should be 6 carbons, and plus with H2O as the side product. So you got your structure, and this structure is what we call as phenylhydrazone. So settle for condensation with ammonia and its derivatives. Let's go with the last chemical reactions of carbonyl compounds, which is oxidation. Basically, this is what you've learned so far in the previous chapter. You are going to oxidize aldehyde to carboxylic acid by using strong oxidizing agent. So you can choose either one, potassium permanganate, sodium dichromate, or potassium dichromate, whichever is fine. So when you use strong oxidizing agent, I emphasize here strong, you will directly form our carboxylic acid. Let's say this is our carbonyl compounds. I'm going to give the numbering so that you can see very clear 1, 2, and 3. At the first carbon, you have carbonyl group. So I'm going to change this carbonyl group into carboxylic acid. So carboxylic acid, we have functional group carboxyl. So from carbonyl, it's going to change to carboxyl. So let's copy back. From the first carbon, you have carbon double bond O and then OH. So this is our first carbon that changed already to carboxylic acid, and then it will bond it to the second carbon. Second carbon, you have CH3 and also hydrogen, and the third carbon you have CH3. And don't forget the side product is H2O. So the observation for this part, when you have KMnO4, the purple color of KMnO4 decolorize. So it shows the positive result because you can form the product here. Please be careful when you draw in this kind of structure. Please count the number of hydrogen atoms and carbon atoms that you have. Make sure it's just the same as the starting material. Next one you have B. So B is our benzaldehyde. You have strong oxidizing agent. So I'm going to change this carbonyl group to carboxyl group. So let's focus. Draw the structure, benzene ring, and then attach to carbon, and this one will be carboxyl. So you have 4 bonds for the carbon. Make sure you double check, and then you got carboxyl group, which is this one. And then don't forget the side product is water. So this is where your potassium dichromate turn green from orange color. Let's go with the next one, C. What I have here is also aldehyde. So aldehyde here is aliphatic aldehyde. What I'm going to show here, let's put the numbering first. 1, 2, 3. So at the first carbon, you are going to put the carboxyl group from carbonyl. Change it because you oxidize this already. So I'm going to draw first my 3 carbon atoms. So this is carbon first, second and third. So fokus kepada carbon yang pertama, awak akan tambah double bond O and then OH. So you got your carboxylic acid with 3 carbon atoms. This is propanoic acid and a plus with H2O. Sekiranya awak gunakan sodium dichromate, dia tetap akan tukar kepada green from orange color. Now we go for oxidation of ketone. How about it? So for your information, ketone are resistant to oxidation because they don't have hydrogen attached to carbonyl carbon atom. Kenapa? Sebab ketone ni dia tak ada reducing hydrogen, iaitu carbon yang ada double bond O, dia mesti attach kepada hydrogen. So dia tak ada. Sebab tu bila kita tulis equation, we can write the equation, but at the side product, you should put no observable changes. Very simple. And then kalau you guna potassium permanganate, the purple color of potassium permanganate remain. And the same one goes for B because we have ketone here and also ketone here. Either you use K2Cr2O7 or Na2Cr2O7 in acidic condition and heat, awak tetap akan dapat negative result. So you should put no observable changes for both of them. So settle for oxidation of ketone. So by now, all of you already learned 4 chemical reactions of carbonyl compounds. Kita fokus spesifik untuk nucleophilic addition dalam video sebelum ni. Dan kita fokus 3 lagi chemical reaction dalam video ini. Harapnya awak boleh bandingkan dan lihat perbezaan macam mana reaction keempat-empat ini boleh berlaku untuk carbonyl compounds. So that's it from me. I will see you in the next video. Bye!